Selective coordination is checked by inspectors in several jurisdictions. These include Phoenix, Arizona, and parts of Florida. There are three primary methods used to verify selective coordination. Firstly, the submittal of coordination curves. Inspectors may request coordination curves to demonstrate that the selected breakers and fuses provide selective coordination. Secondly, field measurements. Inspectors may perform field measurements using instruments like power quality analyzers. These instruments measure short-circuit currents and time current characteristics. Thirdly, verification by a designated professional. In some instances, inspectors might accept certification from a licensed electrical engineer or other qualified professional. This certification confirms the electrical system was designed and installed to meet selective coordination requirements. Failure to meet selective coordination requirements can lead to several issues. These include failed inspections, citations, and in severe cases, stop work orders until compliance is achieved. Selective coordination is critical for isolating electrical faults to the smallest possible area. This prevents widespread damage and service interruptions. It also protects equipment from unnecessary overloads and reduces the risk of electrical fires. It is important to understand that selective coordination requirements can vary. They depend on the specific jurisdiction and the application. Inspectors enforce the codes and standards applicable within their jurisdiction. Selective coordination is a method of overcurrent protection. It ensures that only the overcurrent device closest to a fault opens. This leaves the remainder of the electrical system operating. Without selective coordination, a fault can cause multiple overcurrent devices to open. This results in a widespread power outage. The National Electrical Code, or NEC, contains requirements for selective coordination in specific applications. These include elevator circuits, emergency systems, and critical operations power systems. Coordination curves are graphical representations of the time current characteristics of overcurrent devices. These curves show the amount of time it takes for a device to open at different levels of overcurrent. Engineers use these curves to select devices. This ensures that they coordinate with each other. Specifically, the downstream device should open before the upstream device during a fault. Field measurements involve using specialized equipment to measure the actual performance of overcurrent devices in the field. Power quality analyzers can measure short-circuit currents and time current characteristics. This data is compared to the coordination curves to verify selective coordination. A licensed electrical engineer can provide a certification. This certifies that the electrical system was designed and installed to meet selective coordination requirements. The engineer reviews the design drawings, calculations, and equipment specifications. This ensures compliance with the NEC and other applicable standards. Compliance with selective coordination requirements is essential for electrical safety and reliability. Failure to comply can result in fines, penalties, and even legal action. In addition, a lack of selective coordination can increase the risk of electrical fires, equipment damage, and power outages. Selective coordination is often required for systems like emergency power systems. These systems need to maintain power during outages. An uncoordinated system could shut down the entire emergency system due to a fault. Selective coordination is also important in industrial facilities. These facilities often have complex electrical systems with many interconnected loads. A lack of selective coordination can lead to widespread equipment damage and production downtime. The NEC requires selective coordination for elevator circuits to prevent passengers from being trapped in elevators during a power outage. Selective coordination is achieved by selecting overcurrent devices with appropriate time current characteristics. These characteristics ensure the downstream device opens before the upstream device. The coordination curves are used to verify that the devices coordinate with each other. The engineer plots the time current curves of the upstream and downstream devices on the same graph. The curves should not intersect. If they do, the devices are not selectively coordinated. The field measurements are used to verify that the overcurrent devices are operating as designed. The power quality analyzer measures the short circuit current at the fault location. It also measures the time it takes for the overcurrent device to open. This data is compared to the coordination curves to verify selective coordination. The licensed electrical engineer reviews the design drawings, calculations, and equipment specifications. This ensures that the electrical system complies with the NEC and other applicable standards. The engineer also inspects the installation to verify that the equipment is installed correctly and that the overcurrent devices are properly set. Selective coordination is an important aspect of electrical system design and installation. It helps to ensure electrical safety, reliability, and prevent equipment damage and power outages. Inspectors play a vital role in verifying selective coordination. They confirm that electrical systems are designed and installed in accordance with the NEC and other applicable standards. To further explain the importance of selective coordination, consider the following scenario. Imagine a hospital with a critical care unit. This unit relies on a constant supply of electricity to power life support equipment. If a fault occurs in a non-critical circuit, but the overcurrent protection is not selectively coordinated, the entire critical care unit could lose power. This could have devastating consequences for the patients. Selective coordination ensures that only the circuit with the fault is interrupted. The rest of the hospital, including the critical care unit, continues to operate normally. Another example is a manufacturing plant with sensitive equipment. A sudden power outage can damage this equipment and disrupt production. Selective coordination can prevent widespread equipment damage and minimize downtime by isolating the fault to the affected area. The process of achieving selective coordination involves several steps. Firstly, a thorough analysis of the electrical system is required. This includes determining the available fault current at various points in the system. Secondly, overcurrent devices are selected based on their time current characteristics. These characteristics must coordinate with each other to ensure that the downstream device opens before the upstream device. Thirdly, coordination curves are generated to verify that the selected devices provide selective coordination. These curves are typically provided by the manufacturers of the overcurrent devices. Fourthly, field measurements may be performed to verify the actual performance of the overcurrent devices. This is particularly important for large or complex electrical systems. Lastly, a licensed electrical engineer should review the design and installation of the electrical system. This review ensures compliance with the NEC and other applicable standards. The NEC provides specific requirements for selective coordination in Article 700. These requirements apply to emergency systems that are intended to automatically supply power to essential loads during a power outage. Article 700.27 requires that emergency systems be designed and installed to provide selective coordination with all supply-side overcurrent protective devices. This ensures that a fault in the emergency system does not interrupt power to other essential loads. Article 701 addresses legally required standby systems. These systems supply power to loads that are essential for safety, such as fire pumps and ventilation systems. Article 701.18 requires that legally required standby systems be designed and installed to provide selective coordination with all supply-side overcurrent protective devices. This ensures that a fault in the standby system does not interrupt power to other essential loads. Article 702 covers optional standby systems. These systems supply power to loads that are not essential for safety but are important for business continuity. While selective coordination is not specifically required for optional standby systems, it is generally recommended to improve the reliability of the electrical system. Selective coordination is not a one-time task. It is an ongoing process that should be reviewed and updated periodically. Changes to the electrical system, such as the addition of new loads or the replacement of overcurrent devices, can affect selective coordination. Therefore, it is important to reevaluate the selective coordination of the electrical system whenever changes are made. Selective coordination is also important for arc flash protection. Arc flash is a dangerous electrical hazard that can occur when a short circuit creates an arc of electricity through the air. The heat from an arc flash can cause severe burns, and the pressure wave can cause serious injuries. Selective coordination can help to reduce the risk of arc flash by minimizing the amount of time that a fault current flows. This reduces the energy released during an arc flash. Arc flash studies are often performed to determine the potential arc flash hazard at various points in the electrical system. These studies use the time current characteristics of the overcurrent devices to calculate the arc flash incident energy. Based on the results of the arc flash study, appropriate personal protective equipment, or PPE, can be selected to protect workers from arc flash hazards. In summary, selective coordination is an essential aspect of electrical system design, installation, and maintenance. It helps to ensure electrical safety, reliability, and prevent equipment damage and power outages. Inspectors play a crucial role in verifying selective coordination and ensuring that electrical systems are designed and installed in accordance with the NEC and other applicable standards. By understanding the principles of selective coordination and working with qualified electrical professionals, one can create a safer and more reliable electrical system. Remember that this is a complex topic. Consulting with a qualified electrical engineer is recommended for any project involving selective coordination. They can provide guidance on selecting appropriate overcurrent devices, generating coordination curves, and performing field measurements. They can also help ensure compliance with the NEC and other applicable standards.